All right. Hi, everyone. Welcome to the Distributed SQL Summit. I am thrilled to be speaking with David Loomis. David is the Managing Director of Infrastructure, Operations, and Cloud Platforms at Charles Schwab. And we're going to be talking about Charles Schwab's digital transformation journey, right? Talking about how they started with app modernization and then moved on to database modernization as a complement to app modernization. There's a lot of exciting stuff to cover here. Dave, great to have you at the DSS, and I'm excited about what we're going to be talking about. Now, before we get into app modernization, database modernization, distributed SQL, and so on, maybe we can start with a quick introduction. Can you tell us what Charles Schwab does for folks who don't know, and what you do at Charles Schwab?
Yeah, absolutely, Sudha. And thanks first for the warm welcome. I really appreciate it and the opportunity. And as far as covering off on the high level on Charles Schwab, I'd love to share. Charles Schwab really is an industry leader in the banking and brokerage services industry. We provide products and services to retail and advisor clients. The biggest thing that probably really helps people understand our business is that we manage over $7 trillion in assets. So it's a significant portion of the economy within the United States. And it's a really big responsibility for us to help manage that business. As far as my role, in helping our users manage their assets and achieve their wealth management goals, what I do is I actually work in an organization called Infrastructure Operations and Cloud. And specifically, my role is to operate multi-tenant platforms. These platforms are primarily, you can think of them as both public and private cloud for IaaS and PaaS layers, but it also includes distributed databases. So whether or not those distributed databases are within a DBaaS type offering, that is certainly one of the capabilities that we support, but we also support many databases running on bare metal themselves too. So when we get into databases and some of those technologies, it goes a little bit beyond IaaS, PaaS, general SaaS type concepts and DBaaS. We get into actual infrastructure. But at the core of it, my role is to abstract the physical plant itself, the physical plant where networking and compute are all offered, and put these multi-tenant platforms in place so that we can manage them for our application development teams.
Awesome, Dave. And that is first of all a broad charter. It's great to see kind of all the as a service components under one umbrella. So your customers or your internal customers are the app developers and people who are building new capabilities for Charles Schwab. Is that right?
Yeah, that's correct. Absolutely. Everything from our trading systems to our banking systems to the interfaces out to our retail customers. Those are all important, whether it's schwab.com or mobile applications, they all reside on our private cloud infrastructure and our public cloud infrastructure.
Fantastic. And we know that over the past 5 years, but even before that, there's been a tremendous amount of change that has happened in the industry, right? Financial services has gone through a lot of changes. In fact, we are seeing innovation across pretty much every industry that we look at, right? And this is a massive innovation driven by changing customer expectations, changing market dynamics, and so on. Can you tell us a little bit about what you are seeing from Charles Schwab? What are you seeing in the industry? What are the changes that are driving technology innovation today?
Yeah, absolutely. And in the last 5 years, it's certainly a great way to sort of start from discussion. Certainly fintech, which is obviously referred to quite often. So financial technology firms have been a real big focus. How do we, as a very large organization, become more agile? How do we advance concepts? How do we bring products and services to market? And how do we really address the needs of our clients, the access requirements, the true 24-hour, 7-day, 365 a year requirements where we need to provide access to their assets so that they can really manage it any time, any place that they need to. This continues to be a requirement that grows. The basic user interaction is so critical, whether that's responsiveness of an application, whether that's the presentation of the application, which can go down to the mobility aspects of certainly the user interaction. Those are all very important things. But what's really, really important in our industry, certainly, of course, is accuracy. And the accuracy of a transaction where where every transaction counts, where every dollar counts. It counts obviously down to the dollars and cents. So it's a very big change in the sense of availability. The scaling requirements as we grow, as we've gone through mergers over the last 5 years have been critical. And then specifically, I would say in the last 2 years, I think everyone, is across industries of, we've certainly experienced lots of changes, and I think have been surprised in many, many ways. But the volatility that came with the pandemic, the volatility, or what we will refer to as market open, when the financial stock markets, when they open in the day, we see extreme spikes in requests for trades and other financial transactions during the day. We saw that with the pandemic, and then certainly with the meme stock, onset itself, specific stocks, we saw volatility within them. So what really that means from an expectation perspective is we have to provide all of our services at scale all the time, and with extreme volatility now as part of that. So that really has sort of started to drive what are the platforms, what are our availability requirements overall, and how do we architect for the future?
That's a great point, Dave. Across the board, I think we see this need for instant access from anywhere all the time, right? Those are the three drivers, right? If you're seeing low latency access to data, people want their data right now. And I think meme stocks, the thing that you brought up, is definitely an effect that we are continuing to see, right? And it's still continuing, where people want to suddenly crowd around a specific stock ticker and really trade the heck out of it. And I think that is driving the need for, driving expectations around what financial services are providing to these customers. There is almost this retail effect across the board. People expect financial services, their banks and their financial services and trading platforms, to act like pretty much everything else that they are interacting with, like e-commerce. It's a lot of what we call cross-category comparison, right? Their experience on a financial services platform, they are comparing it to their experience on Google or on Amazon in terms of what they expect in terms of responsiveness, right? Massive shift. And I think this is definitely driving changes. It's a good thing that Charles Schwab has been on this journey of modernization for a few years now, right? And I know that you've actually worked with several folks at Yugabyte who were in their previous lives when they were on the pivotal side, on the app modernization side. Can you tell us a bit about where that journey started, right? The app modernization journey. Where did you start? What did that look like in the early years?
Yeah, absolutely. It's a great question, and it has been a journey. And I love the fact that you're pointing out that financial services does have a lot of the similar requirements to what you would expect in the public cloud and many significant SaaS offerings. It's absolutely there, and the journey really has been, I would say, over the last 7 years, right? Containerization at the core of it. How do we really come up with not only a services strategy, but a strategy that is going to enable us to begin the journey on-prem, where we may have significant footprints in many large-scale platforms today that we know we need to get beyond the physical boundaries of the building, or the data center, I should say. And so that journey really led us by looking at stateful apps primarily first. When we looked at the stateful app, we really started to say, I think at the core principle that drove almost everything was not only selecting a container platform that you mentioned, some of the ones that are popular in the industry, especially if we go back a little bit in time, where they were vendor specific versus, let's say, Kubernetes today, which is certainly an industry-wide containerization platform. But what we really looked at in the beginning was 12-factor applications. And that's a really key thing, because as we look at it today, we have a significant portion, a really significant portion of our tier 1 applications and many other applications running in a containerized platform. And it's really proven to be a key to our scalability, our ability to react to whether it's mergers and acquisitions or some of the geopolitical concerns that are going on. How do we move workloads? We have been able to do that very quickly, from data center to data center, from data center to public cloud, because we have containerized our applications, and not only done that, but also adopted those principles of the 12-factor application.
Got it. So you started with stateless apps and then very quickly also wanted to move your stateful applications to the container world. And I think what one of the things that you and I were talking about was this journey for moving your stateful applications to containers also led you to go and revisit the data architecture because you had all these applications that were cloud native, microservices, and running in a hybrid and multi-cloud environments. And you had databases that were not matching your app infrastructure. So in many ways, the benefits of app modernization were limited by the data infrastructure. So you almost that drove the need for database modernization. Can you tell us about that journey? Like how did you discover that and what does the data architecture in this modern cloud native environment look like? What are the ingredients of it?
Yeah, absolutely. So, I mean, I think we go and look at container platforms. If we even look back at, some of the things that you mentioned with Pivotal, and we discussed sort of the tiles and what services really, what constitutes stateful services, and then which ones might be more ephemeral versus durable, I would say. So if we go and we look at messaging, if we look at caching, if we look at the database itself, these are all sort of core technologies that certainly, give us that, that need for different types of resiliency in how we get that management. We absolutely, when we say stateful, it's not necessarily I think a black and white line. There are some services, certainly like caching, that are more ephemeral, and so therefore those are certainly components of that modern application and how we achieve the 12-factor capabilities. There's even other things like object storage, right, where we adopted certainly some industry, what became industry standard protocols like the S3 protocol, which is really, cross all vendors, even on-prem vendors that we have that have adopted that from a protocol perspective. It's really, really important to be observing that and understanding that that's part of, if you're going to manage state, that you have to be able to build these 12-factor stateful apps, and you have to be able to move them to a platform that supports it. I would say that the refactoring and replatforming discussion becomes very, very important when you start to discuss stateful versus stateless and sort of that overall journey. But I think that's, that as we looked at stateful to try to get, straight at that point, is it's really, really important to understand that the complexity goes up significantly, certainly, as you try to manage state and specifically across geographical boundaries.
Awesome. And so you talked about object stores. Let's quickly switch into the transactional database, right? Because I think this was, if you think about how distributed SQL came about, it was basically an architecture that emerged from the shift that was already happening. The rest of your stack looks cloud native, truly scale out, built for resilience, running on commodity hardware, able to deploy in any kind of hybrid or multi-cloud environment. And so what Yugabyte did was to say, okay, how do we apply those same principles of cloud native architecture to the transactional database? So can you talk about kind of how did you discover distributed SQL, and where do you see distributed SQL databases fitting in your database needs or your database architecture?
Yeah, absolutely. Really what we're looking at is just like Kubernetes and the management planes from the different vendors, from all Kubernetes, or I should just say containers right now. The management planes really are sitting above the different public cloud providers or different private clouds. And you have that management plane that allows you to not only scale horizontally within a data center, but scale beyond the data center itself. And I should be really saying beyond the zone and scale to the region, to really manage your data, to shard the data at the database tier, to be able to get the data where it's supposed to be, i.e. the leaders and the followers in many cases. How do you make sure that the data is where the processing is going to be? So when we look at distributed SQL, that very much is at the core of what we're trying to do, is make sure our data is where it needs to be, where we can scale not only within a specific zone, but within different regions, where we can have where we can handle different failure scenarios seamlessly, and certainly at the core of it, right, distributed SQL, to make sure that the integrity of the transaction is maintained across zone and region. So that's really the core of why we began looking at distributed SQL. It was very much to say, let's bring let's bring that compute power to a hybrid approach and the ability to really operate anywhere.
Got it. And when you looked at distributed SQL technologies, what was your kind of checklist of decision criteria? What are the things that you were looking for in the distributed SQL database that you were going for?
I think I think a core tenet is if you look at distributed SQL, it's going back to the principles of ACID, right? So, and what's really different, I think I want to make sure I tie that together, right? So certainly the atomic nature of a transaction. We all get that. The transaction itself has to have the integrity of it. The consistency of your reads and writes is certainly important, and then isolation is too. So what's really, really happening there with distributed SQL from our perspective is durability, and durability beyond the zone and region. So tying that back to sort of some of the previous discussion of stateful applications of distributed SQL, why? It really comes down to, why distributed SQL, why SQL, and the fact that the underpinnings are the principles of the technology all adhere to ACID. And it is so critical, I think, when we think about distributed SQL to think about what the D stands for in durability.
Yeah, that's a great point. And you raised another point earlier, right? You want the data to be accurate. We quip that in financial services, eventually consistent is wrong. The other name for eventually consistent is wrong in many applications because you need the data to be strongly consistent. You need it to be durable. You need that the data cannot be lost. And so a lot of the things we talked about in terms of resilience and availability, even when you may have like region level failures, it's important for the database to be able to survive that. And I think that is definitely an aspect of what distributed SQL databases provide. Now, when you look at use cases where, and again, most large enterprises have not one database that they've standardized on across the board, but they have a mix of technology. So where do you see, if you look at distributed SQL and compare that with traditional relational databases today, are there use cases where you see one fitting better than the other today?
Absolutely. I mean, I'll go back, certainly, over a decade, right? I think some of the original discussion around polyglot persistence, that still applies. Understanding the functional needs of why you have a particular persistent store is critical. So that could be the document storage. It could certainly be more of a key value pair type approach. But absolutely from a transactional perspective, a SQL perspective, it's so important to really understand that an application may have different platforms required. It isn't always a one size fits all. It certainly is easier if we can have, one target backing service that can fulfill more. And I think there is a promise of these distributed SQL databases there where we will be able to have the functional and the non-functional requirements met by these platforms of the future. But it is important to recognize, right, to really understand the application requirements and stay in tune with the application and developer community on what they're looking for, understand the full life cycle of the data that they're managing, how they introduce that, whether that's product catalog to orders to order fulfillment, all the way up through billing, and then certainly analytics. Those functional requirements that all applications have to manage through in the overall life cycle, those are all important. And I would just go back to, it's not going to be a one size fits all, but certainly I think distributed SQL has a very promising future in the ability to meet a lot more of the combined functional and non-functional requirements.
For sure. I think right now there's a debate brewing in the industry about whether distributed SQL is a general purpose replacement for traditional SQL or whether it is a niche database. And I think it is, again, as with a lot of these technology trends, it is a journey, right? Typically you start out with it solving a very specific problem that other databases just cannot. This could be, how do you achieve massive scale with relational and transactional guarantees? That could be the starting point, but then over time that technology expands in scope to become the general purpose replacement. And definitely that is kind of that's what Yugabyte as a company is betting on. We see distributed SQL becoming that general purpose database, to your point. But I think you all start somewhere, and as with at the innovator's dilemma, right, you start with the problem that a traditional technology just does not solve. And that is a big need in the industry, right? And you start from there, and from there you expand into other areas. So definitely, we see that same trend. So it's good to see that. Now, you said that you provide database as a service capabilities internally, right? You provide that PaaS on top of databases. How do you see the experience for you as a team and as a function within the organization, providing DBaaS on top of traditional databases versus on top of distributed SQL? Do you see a difference in the experience for you in terms of ease of operations and providing DBaaS? And I know, when you're using distributed SQL, how is your experience of providing DBaaS to your data developers?
Yeah, absolutely. So DBaaS internally, right, especially our private cloud offerings, we certainly have many different mechanisms where we have, especially if we look historically, been able to build and manage platforms in a multi-tenant fashion, really solve those noisy neighbor issues. And that's everything from onboarding onto some of the traditional relational databases. How do we really make those multi-tenant? How do we ensure that we're balancing compute and certainly having the response times that all of our customers that are residing on those shared platforms demand. So we've done a lot of that from an overall lifecycle perspective, and it goes from the onboarding, certainly, beyond that, the management, the alerting, all of that sort of combined, looking at it holistically of just really how you introduce services and how you manage the lifecycle, all the way through decommissioning of those databases themselves. So when I look at a distributed SQL, capability, some of the things that really come with some of the modern technologies are things that are still challenging with some of the legacy products. The ability to introduce new nodes into the cluster easily, the ability to upgrade and perform currency much more easily, the ability to move them from an on-premise or private cloud offering into a public cloud. We really see the management plane coming with some of the distributed SQL providers, just like I mentioned, the management planes coming with the Kubernetes providers. The management plane is really, really going to be key. And then I think lastly, one of the things that we don't talk a lot about is migration. And if you look at any of the modern platforms that are really out there in offerings in a managed service, they all provide that capability to migrate from different data stores and data types. So that's some of the key capabilities that I see that are going to make a difference. Our ability to scale quicker, to handle, again, those non-functional functional requirements. But at the core of it, how do I get my workloads, or how do I get my databases onto the platform? A lot of it is about having those modern tools and those capabilities available to you to migrate your data so that you can have the data affinity. So not only can the solution self-shard and put the data where it needs to be, you have to get the data into the platform itself.
That's an awesome point, and one that is often overlooked, right? A lot of people spend a lot of time picking a database, but the messy side of how do you get data into it and how do you move data around, that is not something people kind of consider upfront. We take database migration as part and parcel of database operations. You have to think about how to get the data in, how to move from your Oracle or SQL Server or DB2 or whatever database you have onto Yugabyte DB, something that we think about a lot because that's the reality of data, right? Data has gravity and you have to think about how you're going to bring it in. Two rapid fire questions. I know we are coming up at the, on the time. So one, technology for technology's sake has never been how people do innovation. So what are the business outcomes? What are the business benefits that drove you to pick distributed SQL? What are you expecting to get from this database modernization initiative?
Yeah, absolutely. I'll take it back almost to the beginning when we look at any of our business innovations or technology innovations. One of our core principles at Charles Schwab is client experience, and it's always putting the client first. And so what's really driving the innovation is our ability to allow them to interact seamlessly with us at any time and any place. And it's really about protecting their assets, right? Certainly the security requirements that come along to it, the availability, the flexible interactions. There's so many different dimensions and perspectives that are critical, but at the end of the day, it's about our client. And it's about ensuring we're doing the right thing for our client, and that's what's going to drive us in our continued innovation forward.
Awesome. Thanks, Dave. And last question. So everyone, I mean, the theme of the conference is about future proofing and making your infrastructure ready for whatever is coming in the future. What does future proofing mean to you, right? What does it look like to have future proof infrastructure?
For me, I go back to it's all about the interface. And when I look at the interface, I want to be able to look at the interface of a data center, compute and networking. I want to look at the interface of networking and compute around that. And then I want to look at even public cloud, edge providers now, and certainly private cloud. And I want to say, well, what are the interfaces of the future? One of the things that I think is really important to observe as we look throughout this is that we continue to see many of the core, what I would say, runtimes around caching, around databases, really start to become the interface because many of the providers have adopted these core database technologies as their engine. But what we've seen is since they're now common and well understood interfaces, that they themselves become the interface for others to implement different database engines or different storage technology engines below them. And so whether or not, it's things that jump out, I mentioned the S3 protocol earlier, that's about object storage. Certainly you see sort of Redis a lot within caching. It's really about portability in that case. And then same with Postgres, as an interface. We see a lot of these things actually becoming a way to view portability. And that's, I think, how you future-proof. It's about the interface. It's about understanding that, yes, your data will need the affinity where they're going to run those workloads, but can I move those workloads around? Can I re-platform them if I have to, with hopefully a minimum amount of refactoring? And so I see that as the future-proofing. Make sure that you observe, get beyond the product names of what you're building towards or the platforms you're implementing, and truly just sort of understand those basics of a modern application. Do you have those capabilities available to you?
Awesome. Dave, we always run out of time before we run out of topics to discuss. There's so much more that we can dig into. Thank you for this fascinating conversation, and wish you and the Charles Schwab team continued success on your database modernization and digital transformation.
Okay, thank you so much, Sudha. Really appreciate the time. It's been a lot of fun today.
Thanks, everyone.